Section 2.7c, transforming general functions. Hey, I just wanted to give you one last example of the way transforming can work. This is an optional video, that's fun, but that won't let some people not watch it. And if I'm saying what I think I'm trying to say, I mean that some people don't even watch the regular videos, and they certainly won't be watching these, right? I'll try to throw in tons of humor so that those that actually watch this can have lots of inside jokes, but it probably won't work very well. Anyway, let's get to the example. I'll keep it short because it's an optional video. Okay, I have this following function, f of x. f of x is in red down here. It's a collection of a bunch of random points, and I made the points in the shape of a G because my last name starts with G. Also, G happens to be the first letter in the word gangster, which is nothing like what I am, but we're going to transform this function, so we're going to transform it this way. Now, remember, when we are transforming functions, we need to work in good order of operations. That means before I take care of the addition and subtraction, I need to take care of the multiplication. So I'm first going to do this -2. That means every single y value for every single one of these points is going to be multiplied by -2. So let's do this one first. Its y coordinate is 3. So when I do the reflection, that'll put it down here at -3, but then it's times -2, so that'll actually put it at -6. So that's that one. Next, I have this guy. He's at y coordinate of 1, so the reflection puts it at -1 times -2 puts it at -2. And I'll go ahead and connect the dots as I go, just so I kind of make sure I have the lines drawn in the right order. This guy, he's at -1, so he will be at +1 when I multiply times the negative, and +2 when I multiply by the -2. This guy next, he's at +1. Actually, both of these guys are at +1. So when I multiply them by -2, they will both be at -2. All right, so here's my new function, and I've multiplied by -2. You can see the G is kind of stretched out, and it is now upside down. So it looks like I did it right. Next, I need to take care of the -1 and the -3, so let me shift to a gangster ink color of green. Just kidding, I don't know what I'm talking about. This -1 means I'm shifting to the right by 1. Remember, it's opposite. This -3 means shift down 3. So I'm going to take each of my points in my kind of halfway transformed function and move them in those ways. And I don't really need to work in order here, but I still will. I'll do this point first. It's over 1 and down 3, which puts it here. This guy, over 1 down 3, puts it here. And again, I'll connect the dots as I go. This guy, over 1 down 1, 2, 3, puts it here. This guy, over 1 down 1, 2, 3, puts it here, and then the last point should be right next to it, right? And if you actually went over 1 down 3, you would see that's the case. So my lines are connected in this way, and this green function is my final answer. That was the worst arrow I've ever drawn. Anyway, the green function is the final answer. Remember, start with multiplying by the -2, and then shift over and down. Did I make funny jokes with the G's and everything? Well, even if not, I kept the video to under 4.5 minutes, so go me. Thanks for watching this optional video. I hope it helped you just with transforming general functions.